next section in polynomials is adding and subtracting polynomials. Adding and subtracting polynomials is as simple as adding like terms. For example, we see two polynomials here. These two polynomials can be added together by simply adding like terms. And there's a couple of ways to do this. Initially, when I learned to add polynomials, I lined up my polynomials underneath each other and put the like terms underneath each other vertically, like the example you see here. Then you just add. It's very simple. So we have 5x cubed plus 3x cubed is 8x cubed. 6x squared plus 2x squared is 8x squared. 8x plus x is 9x. 15 plus 5 is 20. And there's your answer. After getting used to adding like terms when you add polynomials, you may just look at the two polynomials and add the like terms. You can see how I used color and different symbols to help me quickly see which terms are like terms, and I added them to get the same answer. So here are two approaches for adding like terms when you add polynomials. Now, what can happen is you can end up with terms that are missing. For example, in our first polynomial, let's say we did not have an x squared. And in our second polynomial, let's say we did not have an x. What I would have written is 0x squared here, and I would have written 0x here to help me line up all of my like terms. So that's a technique that you can use. Try adding these two polynomials and then check to see if you're correct. Here I have both lined up my two polynomials with like terms underneath each other, and I've highlighted my like terms in case I just wanted to skip the step of rewriting the polynomials. Either way, I get the same answer. Next, try adding these two polynomials, keeping in mind that if you are missing a term, that you can use 0x squared, for example. If there's no term with x squared, you put a 0 in front of whatever variable you need. Or just make sure that you are adding only like terms, however you'd like to approach it. Give this a shot and check back. Here are my steps and answers. Again, you can see where I've highlighted my like terms if I want to just add these up visually. You could add them up as you go. For example, 3x cubed plus 9x cubed is 12x cubed, and then cross out those like terms and keep moving that way. You can see we only have an x squared. Negative 6x and negative 7x is negative 13. So negative 6x plus negative 7x is negative 13x, and 2 plus 1 is 3. So you can add your like terms the way I just showed you in addition to vertically. Try the next two problems and check back to see if you have the. Here are my steps for the first problem. Here are my steps for finding the answer to the second problem on this page. Now notice I put in a lot of terms with a 0 as the coefficient. You don't have to do this. However, I think it's really important to understand that that's what's actually happening here. So when you don't see an a to the 6th at all, that means the coefficient is 0. Just like when we don't see a variable, that means the exponent is 0. So understanding things like a means a to the 1st, no a means a to the 0, no term at all means 0 times a to whatever exponent's being raised. Understanding these little tiny details helps you to have a deeper understanding of the algebra you're working with. Let's talk a little bit about opposites. So if you think about opposite of 4, we know that the opposite of 4 is negative 4. If we think about the opposite of 4x plus 1, the opposite of 4x plus 1 is negative 4x plus negative 1. Well, we're going to be working with polynomial opposites, which is actually what I just showed you in the second example. The way that you find the opposite of a polynomial is you distribute a negative to each term within the polynomial. So let's look at an example. Here we have this polynomial and we're going to find the opposite of it. Now I think it's a lot easier to work with opposites if all of our terms are being added together. In other words, I always change any subtraction to addition. In this particular example it's all addition, so that's not an issue, but you'll see me changing to subtraction to addition later. So we're going to find the opposite of this polynomial by distributing a negative through the entire thing. So here we have the opposite of the polynomial. Opposite is written as a negative outside of parentheses, so we're going to distribute. In doing so, the opposite of 4m to the fifth should be negative 4m to the fifth. The opposite of m squared should be negative m squared. The opposite of negative m should be m, and the opposite of negative 16 should be 16. So these two polynomials are opposites of one another. Try the next two examples and then check back. Here are my steps for both polynomials. Again, I changed all subtraction to addition in the second polynomial before distributing my negative. That way I'm very clear what the signs are of each of my terms. When you subtract polynomials, you take the first polynomial, subtract the second polynomial, and so what you're ultimately going to be doing is changing subtraction to addition. Just like, for example, if we were working with 16 minus 20, we would actually change this to 16 plus negative 20, which would give us negative 4. We're going to do the same thing with our polynomials, only our second polynomial, instead of just making it add the opposite, we're going to have to make it add the opposite and then distribute that negative throughout the second polynomial as we just practiced. Here's our first example. We have a polynomial minus another polynomial. So again, we're going to change this to plus a negative, which means plus the opposite of this second polynomial. Now that I've changed subtraction to addition, I have my opposite sign outside of the parentheses for my second polynomial, and I can distribute it through. Like with our previous examples, I can have my polynomials lined up on top of each other and distribute the subtraction through, or the opposite symbol, through the second polynomial in this vertical order. Or I can work with the polynomials next to each other. So I'm going to start that way this time, and I'm going to come through and distribute that negative. So I'm going to erase this negative symbol and go through and change all of the signs of each of my numbers. When I do that, I can clearly see the signs of each number. So I'm going to rewrite this to make sure it's clear. Next, I'm going to highlight like terms. So I have 8m to the fifth plus 3m to the fifth, negative 7m to the squared, 8m squared, negative m, negative 9m, 6, and 1. So I'm going to go ahead and add these. 8 and 3 is 11m to the fifth, and I'm going to mark those out so I can remember that I've used them. Negative 7 plus 8 is positive 1, so that's m squared. I'm going to mark those out. Negative m plus negative 9m is negative 10m. Again, I'll mark those out. 6 plus 1 is 7. Now, as I showed you, I also did this vertically. And so let's see what I get. I should have the same thing. And what do you know? I do indeed. And you can see here where I changed my subtraction to addition and found the opposite sign for each of my terms before adding. Try these two examples. Again, I recommend that you change all subtraction to addition before distributing the negative. So here are my steps for these two problems. Notice this time I worked with these horizontally instead of writing them vertically, so you can see some examples of me doing it both ways. Something to keep in mind is that you really need to simplify all of your polynomials before adding or subtracting. You may also have noticed that I always write my answers in standard form, which is also important. So here we have an example where we need to work with distribution here and here, and then add any like terms if possible. So let's look at the steps. So in the first polynomial, I went ahead and I just wrote these on top of each other. Actually, I haven't done anything yet. Then in this step, I went ahead and simplified using the distributive property. So negative 2 times 8m cubed was negative 16m cubed, and I continued to distribute. And then I did the same thing in the second example. I distributed. Now you'll notice that I need to add some like terms in my first polynomial before I continue to work. So in my second step here, I added my like terms 2m plus 4m to get 6m. I also inserted some zeros to help me line everything up. I changed my subtraction to addition up here and distributed that negative throughout my parentheses to find the opposite of the second polynomial. And so there's the opposite as my second polynomial. Then I went ahead and added, and here's my solution. Now I did end up with a 0 as one of my coefficients, so I need to simplify that further by dropping it. We don't want to write that in our final answer. Skip the next two problems, as they are actually the same problems we just did in the last example, and let's move on. Try the two problems on the next page that says more practice, and then check back. Here are the steps and answers to the first problem. In part A, I simplified. In part B, I added the two polynomials. And in part C, I subtracted the two polynomials by adding the opposite of the second polynomial. In the second problem, part A, again, I simplified each polynomial. Part B, I added the two polynomials. And part C, I subtracted the second polynomial from the first by adding the opposite of the second polynomial. In this last example, we're going to think a little bit in terms of inverses. So here we want to figure out what term in each polynomial that has a question mark is missing in order to get the answer. So what would we put right here in order for 10m squared minus m minus 7 minus something to equal 10m squared plus 4m minus 7? So take a second and see if you can figure it out and then check back. Hopefully you ended up with an answer of negative 5m. So as you see here, if I come in and I change the subtraction to addition and change that negative 5 to a positive 5, 5m plus negative m gives me 4m, which is what I need to be working with, this piece and this piece, to equal that term. The negative 7 is already a negative 7, 10m squared is already 10m squared. So we have a couple more examples, just two more. Go ahead and try these and check back. For number 2, you should end up with 4a squared. And in number 3, you actually ended up needing to add 3 terms, or a trinomial, in order to have this polynomial, this first polynomial, congruent to the second polynomial.